question 1, we've got to write 6324 correct to the nearest thousand. Okay, if it helps, think of it in terms of money. So you've got 6324, and if you're struggling with this at all, you've got to remember these are your units, your tens, your hundreds, and these are your thousands. Okay, and the decimal point would belong there. So we want to write this correct to the nearest thousand. So what we're looking at is that number there. Now, if it helps, think of it in terms of a number line. So you've got either 6,000 or you've got 7,000, and you're trying to place where does this number now 6,324, because 6,000, 300s, 2 tens, so 24. Where would that go along this scale? Would it be closer to 6,000 or 7,000? Because it's a 3 there, this middle bit would be 6,500. So it's going to be somewhere in between there. So correct to the nearest thousand now, that would be closer to this one rather than this one. So it would be 6,000. Okay, question 2a says write the following numbers in order of size starting with the smallest number. Okay, now if it helps in this one, what some people like to do is think of it in terms of temperature. Now, first of all, when you're looking in terms of temperature, you want a vertical line to represent your numbers. And what you should know by now, if this is a number line, okay, as you go up, you're adding, and as you're going down, you're taking away. So the more negative you go down that way, the lower you're getting. Okay, so let's start with the easy numbers. Okay, first 0, where does that go? That goes directly in the middle there. Okay, then think the next number 6, and then the number 12. That should be fairly straightforward. If that's 6, that would be 12. So now you can see those are already in order. Where people struggle in this is more to do with the negatives. Okay, so let's compare -6 and -5. The mistake some people make is thinking, oh, 5 is less than 6, so 5 is smaller than -6, and that doesn't work in the negative realm, because when you go down here, you've got to think what's more negative, -5 or -6. If this was temperature, what would be colder? In this case, this one would be the more negative. So if -6 is down there, and -5 would be just above it. So now you can see the order going upwards, starting from the smallest, go -6, -5, 0, 6, and 12. Okay, so the key thing with negative numbers, rather than thinking of it as a horizontal left and right situation, try to think of it as an up-down, and you'll start to see that it will start to make a bit more sense. Okay, part B says write the following numbers in order of size, start with the smallest number. Okay, now first of all, if you look at this number, does this say 0.78? That's incorrect, because there's no tens, so it's not 70. That's not 70. That's actually 0.78. If you write that correctly, you should find that this would not ever be said as 78. The only time where that's not really true is if you were thinking it in terms of money and you said how many pounds was that, you would say 78 pence. But that's in terms of pounds, it would still be £0.78. Okay, so exclude money in this case, but the best way to compare these, okay, is first write them out so they all have the same digits. Now, if you think about this number here, you can add as many zeros as you want at the end and as many zeros as you want at the beginning, and it makes no difference to the number. That's still 0.078. All of these and all of these are insignificant, and that kind of helps us in this question, because now if I want to compare these, I want them all to have the same number of decimal places. This is 3 decimal places, this is 2, this is 2, this is 3. So let's make them all have 3 decimal places, 0.078. Now this one will be 0.78. If I add a 0 at the end, does it make a difference? Nope, it's still 0.78. So do you see why we don't say that's 0.78? This isn't 0.780, this is 0.780, and this is 0.78, okay? This 1 to 3 digits would be 0.870, and this one's already 3 digits. Now we've written them so that they all have 3 digits. Now you can really compare them. If you ignore the decimal now you can see which one is the smallest. The smallest here would be 0.078. Now the next smallest out of these 3 would be 708 compared to 780. So 0.708. The next one, so which ones have we done? We've done that one and that one. And then out of these 2, you can see they're already in order. So 0.78 and 0.87. Okay, question 3, it says write 20% as a fraction. Okay, now technically it's already written as a fraction because what does this symbol mean? That means it's 20%. And if you think about words that start with this, things like century, I guess there's other things. I mean, in terms of money, cents. If you've ever been to America or into Europe, you'll know that cents represents 1 out of 100, meaning a dollar or a euro. Okay, so if you think about what this is actually saying, it's saying 20 per, meaning out of, and cent, like century, out of 100. So actually, it's already a fraction. It's 20 out of 100. And you don't actually have to, because it's only 1 mark. You don't have to simplify, but good mathematicians here will realize actually you can make this into a simpler form. Let's divide them both by 10. So we've got 2 out of 10 now. And then 2 out of 10 can divide by 2, so we get 1 out of 5. So 20% as a fraction will be 1/5. Okay, question 4, it says here is a list of 4 fractions. Okay, you got 4 out of 16, 2 out of 8, 15 out of 60, 3 out of 9, and it says one of these fractions is not, and notice that's in bold, not equivalent to 1/4. Okay, think about what that means. Equivalent is the same as a quarter. We need to write down this fraction. Okay, now some of you should be able to kind of spot this straight away. There's one of those that seems very out of place compared to the rest. Okay, but it's always a good idea to take it slowly and do each one and see if they are equivalent to a quarter. Then that means they will simplify to a quarter. So let's see, if I simplify this one, that means if I divide both the top, the numerator and the denominator by the same thing, okay, then the fraction itself stays the same. So if I divide these both by 4, how many 4s in 4? There's 1. How many 4s in 16? So that one is a quarter, so it's not this one. Okay, the next one, 2 out of 8, this should be fairly straightforward. We can divide both of those by 2. And that gives us a quarter. So it's not this one either. Now this one is slightly tougher to simplify because you can't just half it or divide by an easy number. In this case you have to divide by what goes into 15 and 60. Well, it ends in 5 or 0, so that means we can divide it by 5. Okay, how many 5s in 15? There's 3. How many 5s in 60? 12. Okay, now that's not equivalent to a quarter yet, okay, but we can divide this further because 3 goes into 3 and 12. So if I divide them both by 3, how many 3s in 3? There's 1. How many 3s in 12? There's 4. So that's also a quarter. And finally the last one, 3 out of 9. What can I divide both of these two by? I can divide them by 3. So 3 divided by 3 is 1. 9 divided by 3 is 3. So this one is your odd one out. Okay, all of these were equivalent to a quarter, and it said one of the fractions is not equivalent to a quarter. That would be 3 out of 9. Okay, question 5, it says write down the first even multiple of 7. Okay, so we need the multiples of 7. So if we multiply 7, what do we get? Well, 7 times 0 is just 0. 7 times 1 gives us 7. And the first even multiple will be 7 times 2, which is 14. So the multiple of 7, the first one that's even, would be 14. Okay, question 6a, simplify 3 times 4t. Now, in algebra, what you've got to remember here, when you've got a number and a letter, or if you've got two letters right next to each other, that means they're being multiplied. What this is actually saying is 3 times 4 of t. Yeah, so if you imagine, if I'm timesing that together, what I end up with, if I've already got 4 t's and then I'm timesing that by 3, what we actually end up with is saying 3 times 4 times t, which gives us 12t. Now, for this one, it says simplify 8a minus 3a plus 2a. If it helps, think about what a could be. It could be apples, okay? If I've got 8 of apples or 8 apples, then I minus 3 apples, that gives me 5 apples, right? And then I need to add 2 apples. So altogether, that gives me 7 apples. Okay, these are all like terms, so you can add and subtract them as you like. What you can't do, if this was, for example, 8 minus 3a plus 2a, you can't do 8 take away 3. That's saying you've got 8 pounds, take away 3 apples. Will that suddenly give you 5 pounds? No, these aren't like terms. So you've got to be careful with that. In this case, they were all like terms. So you just add and subtract them as it's saying it. So 8a, take away 3a is 5a. Add the 2a, gives us 7a. Okay, question 7, it says here is a probability scale. It shows the probability of each of the events A, B, C, and D. And there you can see the scale. Okay, part A, it says write down the letter of the event that is certain. Part B is write down the letter of the event that is unlikely. Okay, now probability always goes, it's not very well shown here, from 0 to 1. Okay, so if something has 0 probability, that means it's impossible. There's just no chance of it happening whatsoever. Okay, if it's got a probability of 1, then that is 100%, that's definitely going to happen. And probability will always be either a decimal or a fraction because it's between 0 and 1. You can't have more than 1, you can't have less than 0. Okay, so write down the letter of the event that is certain, that is D. Now, where a lot of my students made the mistake is here saying write down the letter of the event that is unlikely, thinking that A is unlikely as well. I guess in a way I can understand your thinking, but A is impossible. It's not just unlikely, it just can't happen if it's 0. Whereas one that is unlikely, as you get closer to certain, the more likely it is. So the unlikely one here would be B. Okay, now for the next question, it says there's 12 counters in a bag. Okay, 3 of the counters are red, 1 of the counters is blue, 2 of the counters are yellow, and the rest are green. Caitlin takes that random counter from the bag. If it helps, let's draw a little picture of what this bag could look like. Okay, we've got 3 counters that are red. So let's put our 3 reds in. And obviously in the exam, you'd only be able to use black pen, so you can label them as red there. Okay, 1 of them is blue. So we've got 1 blue there. And 2 are yellow. Oh, that's bright. 2 are yellow, and the rest of the counters are green. Now, there's 12 counters in the bag, so how many must there be green? Well, let's see. There's 1, 2, 3, 4, 5, 6. Okay, so if there's 12 counters in the bag, that means there's 6 left that are green. That's 4. That's So those are all the counters that are in the bag. Okay, now it says Caitlin takes at random a counter from this bag. We need to show that the probability that the counter is yellow or green is 2/3. Okay, so separating that there, what's the probability that it's yellow or green? How many yellows and greens are there? There's 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 yellows or greens out of a possible 12 counters. Is this possible to simplify? Yes, it is. We can divide them both by 2. That gives us 4 out of 6. And then we can simplify that again, which is 2/3. So the key thing to show here is that you've got 8 out of 12, and that simplifies to 2/3, because using this picture really helps you kind of get an understanding of what all these words mean. Okay, question 8 says 3 kilograms or 3 kg of meat costs £54 and Nina buys 2 kgs of the meat. Okay, evidently she's being a bit of a cheapskate. She could have just bought all 3, but no, she's going to make us work out what the price of 2 kilograms is instead. Okay, so if 3 kilograms is £54, we need to try and get to the price of 2 kilograms. That's what we need to know. Now, before we start, we can't go, I mean, we could go straight to 2 kilograms. How would we go from 3 to 2? Well, what do we need to divide it by? Well, 3 divided by 2 will give us 1.5. So we could divide that by 1.5 to get straight there, but that's quite difficult dividing by decimal. There's a simpler way, what's called the unitary method. Okay, so if I work out what 1 kg is first, so what would I need to do to go from 3 kg to 1 kg? I'd need to divide it by 3. So that means I need to do the same here. Okay, if you struggle with that at all, use the bus stop method. This bus stop method can really save your life when working these things out. Okay, how many 3s in 5? There's 1 3 with 2 left over. How many 3s in 24? Is 18. So that means 1 kilogram is 18 pounds. And then if we want 2 kilograms, how would I go from 1 to 2? I need to double it. So that means I need to double this here. Again, you can work that in your head. I always say it's better to work it out properly, just to make sure that you're doing this correctly. 8 times 2 is 16. 1 times 2 is 2. Add the 1 gives us 36 pounds. So how much does Nina pay? She pays 36 pounds. Okay, question 9. The center of this circle is marked with a cross. Okay, part A says write down the mathematical name of the straight line shown in this circle. Okay, now when you're looking at circles, think of a car wheel. So say for example, if this was a car wheel with 5 spokes. Now if I said that this wheel are a set of 18-inch rims, okay, what are we talking about? What is 18 inches here? Now the answer to that would be, how would you measure this? It'd have to be the distance from one edge of the circle to the other. Okay, and it has to go through this center because that's the largest part. If you decided to measure it from here, that's not going to be the longest part of the circle. It's going to end up being shorter compared to this one. Okay, so that's what we call the diameter. That's the normal way that we would measure circular objects. Okay, now this one only goes from the center to the edge, so it's not the diameter, it's not all the way across. This one from the center to the edge is known as the radius. Okay, and this is really important for when you're working out the area of a circle. And it's also important to know, because in this next bit it says write down the mathematical name of the straight line that's touching the circle. A lot of people put diameter here thinking that's the diameter. That's that's got to go from one edge through the center to the other edge. This one clearly is nothing to do with the diameter. What we call this line that touches the edge of the circle there, that is known as a tangent. Just like I went on a little bit of a tangent here, okay? What this is important to know about, okay, is the tangent meets the radius at 90 degrees. So when you're looking at things like, trolley wheels or the wheels on a car, so if this was a car, you would have the suspension brackets. If you imagine there's a spring there, and that would meet the radius of this circle always at 90 degrees. And that's really important for engineers to know and to be able to design their systems really well. Okay, question 10. Tim and 3 friends go on holiday together for a week. The 4 friends will share the cost of the holiday equally, and here are the costs of the holidays. Okay, so it's £1,280 for 4 return plane tickets. So that's all 4 of the tickets. £640 for the villa, £220 for hire of a car for the week. And we need to work out how much Tim has to pay. Okay, now notice it said the 4 friends will share the cost of the holiday equally. That's really useful because that means everyone's going to pay the same amount. So first of all, how much do they need to pay altogether? Well, we need to add these 3 things up. Okay, little exam tips. Don't do things like keep the numbers really small and next to each other. Give yourself a little bit of space and write everything, okay, in order. So if that's the decimal point there, 640, they must go in order of units, tens, hundreds, thousands. So 220 goes there. And if we add those up, that gives us 0. 8 plus 2 gives you the 10, plus 4 gives you 14. So put the 4 down, carry a 10 over. And then 6 plus 2 is 8, plus 2 is 10, plus the 1 gives us 11. So put the 1 down, carry another 1. It gives us 2,140. So that's the total cost that they need to pay. Okay, and if they're going to share the cost equally, that means we're going to divide it by how many people there are. There's Tim and 3 friends or 4 friends. So I need to do 2,140 divided by 4. Now notice when using the bus stop method like this, okay, it's important that you give yourself space and you do this really clearly. Where most people make errors, they put the numbers so close together, you're more likely to make mistakes. Okay, so how many 4s in 2? There's none. So we carry that 2 along, that becomes 21. How many 4s in 21? There's 5. And there's 1 left over. How many 4s in 14? There's 3. And you've got 2 left over. And how many 4s in 20? That would be 5. So how much does Tim have to pay? That will be £535 each. Okay, if you have time at the end of the exam, it's always useful to times that by 4 and see does it get back to that original amount to check your answers. Okay, another way that people would have divided this, you can do it like this. If you want to do 2,140 divided by 4, you can write it as a fraction and then just keep halving it. So if I half that, half of 2,000 is 1,000, half of 140 is 70. 1,070 divided by 2, and then half of 1,000 is 500, half of 70 is 535 over 1. So whichever way you decide to divide it, okay, if you're not already used to this bus stop method will save your life. The more you get used to being able to do this by labeling it out clearly, doing everything neatly, one step at a time, okay, the more you're going to find that maths becomes suddenly so much easier. Question 11 says, write down an example to show that each of the following 2 statements is not correct. Okay, quite a few of my students got messed up on this by not realizing that it didn't say correct, it says not correct. Okay, Now, the factors of an even number are always even. Okay, what is a factor first of all? Okay, the factor of an even number. Factors are numbers that divide into a number. Okay, so let's think of an even number. Let's say, for example, let's look at the number 10. What are the factors of 10? Well, we know 1 times 10 gives us 10, and already that's an odd number. 1 is an odd number, so technically all numbers will have an odd factor because 1 will go into any number. Okay, just to show you as well, you could have done 2 times 5, and this is a factor of 10 that is also odd. So this, as an example, that shows you that the factors of the numbers aren't always even. Okay, for part B, it says all the digits in odd numbers are odd. Okay, let's think of a number, for example, 21. Okay, are all the digits in this odd? Well, this one's odd, but 2 is an even. So there's an example where the digits in odd numbers are not odd. Okay, and just to double check, it said write an example to show that each of the following 2 statements is not correct, and each of these show that they are not correct. Okay, question 12. A shop sells desktop computers, laptops and tablets. The composite bar chart shows information about the sales over the last 3 years. Okay, so a composite bar chart. A composite bar chart is one that's made up of different elements like this. So you can see the black spaces there represent desktop computers, the stripy ones represent laptops, and the grayed area represents tablets. So it says write down the number of desktop computers sold in 2015. So that's where we're looking at this bar here in 2015, and desktop computers is in black. So you can see the area covered from 0 to 100. So therefore that tells us the number sold in 2015 is 100. Okay, then it says work out the total number of laptops sold in the 3 years. Now this isn't quite so simple. The main mistakes that people make, they think, okay, so laptops, the stripy area, that must be that area there. Now let's go through the scale first. From 0 to 100, that's where you can see the scales going up in hundreds. So what does each one of these tiny little boxes represent? Now, the best way to think about that is don't count the lines there. That's where you run into errors. But if you think about it in terms of how many spaces are there, there's 1, 2, 3, 4, 5 spaces. And from 0 to 100, if we split that into 5, that means each space is worth 20. So if this bar here ends at 200, and there's 3 boxes there, that will be 260. Now, that's not the actual amount of laptops there, because what you're not measuring is the height from the whole thing. Because if there's 100 desktop computers there, okay, and then you need the laptops. Now, what if there were more desktop computers sold than laptops? You could see that the bar would end up overlapping each other. You wouldn't be able to see it. So where does this region start from? It starts at 100. So the difference between them, the number of laptops in 2015, will be 260 take away 100, which gives us 160. Okay, we want it for all 3 years. So if I do the same thing here, this line here represents 300, and there's 20 and 40, so 340. And this one represents 120. And if you find the difference there, that will be 220 in 2016. Just move that. Okay, so it's a bit easier to see. So 220 in 2016. And in 2017, this bar begins at 160. This one ends at 440. And again, this one to take away, Some people ran into errors and they try to do 6 take away 4 in their heads. The best way to do this one, I would say, is to actually just write it out. If you struggle and you make silly mistakes in an exam, which most of you probably will, okay, you can't do 4 take away 6, so you need to borrow. 14 take away 6 is 8, 3 take away 1 is 2, so this space represents 280. And then we want to work out the total number of laptops sold in the 3 years. If I add those together, 280, 220, and 160. Those give me 0. 8 plus 2 is 10, plus the 6, that's 16. So we put down the 6, carry the 1, that's 3, 5, 6. So the total number of laptops sold in the 3 years was 660. Again, what I want to point out is look how much writing that there is on the page that's involved in these 3 marks. That's really important. Even when you're subtracting, even when I was doing it here, it's a good idea. If you struggle in these questions, if you got this one wrong when you've tried it before, don't be afraid to put down your working. This writing here is so important. I'm a maths teacher for over 20 years and I can tell you that I need to do the writing just to make sure I'm accurate. I could probably do this in my head. I could probably do it really quickly in my head, but what's the point when you can do it accurately in an exam situation? That's so important as part of your exam technique to know. Okay, part C says state the item that had the greatest increase in sales over the 3 years. Give a reason for your answer. So which item? It's going to be one of these 3, tablets, laptops, or desktops, okay? So let's look at desktops first and see the increase in sales. You can see it went from 100 to 120 to 160, okay? So that's had an increase of 60. So if you think about it, it's this amount of space. How much space are they covering each region of each bar to tell us which one had the greatest increase? And you can clearly see that the grey one starts very small, more than doubles again. And you can clearly see that the others don't double even once. So the best way to put this would be to say, first of all, the grey area is tablets, and we're going to say tablets have more than doubled. Laptops and desktop computers therefore the most. Now mine's a bit of a long-winded answer there. You're probably thinking that's quite long writing all that sentence out, but it's not so bad. I mean, you really got to think about it. What we're saying here is not enough just to say, oh, the grey area's gotten bigger. That might get you, but what's worrying me there is the 2 marks. To ensure the 2 marks, I think it's worth saying that actually if you look at the grey has more than doubled. That one went from there and it more than doubled in size, and then it more than doubled in size again, so it's gone up by a factor of more than 4, whereas this one hasn't doubled, and even this one's not even double that one. So you can clearly see this one's only had a small increase. So this is really a test about your visuals and can you really read this graph properly and take the information correctly from it. Now the next question is a bit more common sense. It says, Alex says, in 2017, more tablets were sold than desktop computers. This means the shop makes more profit from the sale of tablets than from the sale of desktop computers. Is Alex correct? Okay, now you would think that, okay, well,
simplistic thinking would think, if I sell 10 tablets and I sell 9 desktop computers, then obviously I sold more of them, so I'd make more money. But what if the tablet costs, say, £50 and a desktop computer costs £1,000? Then clearly you can see that actually if you sold 10 of these, which is still more than 9 desktops, that's not necessarily going to mean that you make more profit. So what we would say here, okay, you need to mention that the price is unknown, so it is not possible to know which item, I should say, to know which item was more profitable. So Alex says, is Alex correct? I would say no. The price is unknown, so it's not possible to know which item was more profitable. If you don't know the price of them, you can't say for sure either way that it definitely meant that they made more profit. Okay, question 13. A piece of wire is 240 centimeters long. Peter cuts two 45 centimeters long, lengths off the wire. He then cuts the rest of the wire into as many 40 centimeter lengths as possible. Work out how many 40 centimeter lengths of wire Peter cuts. Okay, I think the best way to kind of attempt this type of question is to think about it visually. Okay, so I'm going to start off with, let's say that this is the wire, and that is 240 centimeters long. So that's the wire that Peter is cutting up. Okay, and he cuts off two 45 centimeter lengths off the wire. So if you imagine, he cuts off, let's say that's 45. I'm not measuring it accurately, I'm just kind of seeing it just to see how much is taken off. So if that's 45 and that's 45, okay, then altogether, if you add those two together, he is cutting off 90 centimeters. Okay, and it says that he then cuts the rest of the wire to as many 40 centimeter lengths as possible. Well, first of all, what is that length from there to there? Because we've cut that piece off, so what is that length? How would we work that out? We would need to find the difference between 240 and 90. So if I subtract 240, take away 90, so I'm subtracting 90 from 240, that gives us 0. You can't do 9 take away 4, you have to do 4 take away 9, which is not possible. So I borrow from there. 14 take away 9 gives us 5. 1 take away nothing, it's just a 1. So that means that is 150 centimeters left. That's the first thing that we needed to work out there. But we need to know how many 40 centimeter lengths of wire can Peter cut. Again, you can take different approaches from it. You know, I would think of it in terms of division. How many 40s go into 150? 150 divided by 40. It's quite nice because you can just cancel out the zeros, which means you're dividing both the numerator and denominator by 10. Okay, if I divide them both by 10, the value doesn't change, so it's the same as 15 over 4, okay, which is 7.5 over 2. Thinking, would this be the best way? Would this be the way most of my students would not have done it that way? I would say from this point, 15 over 4, let's just divide it using a bus stop. How many 4s in 1? None. 1 carries along. How many 4s in 15? There's 3. And at this point, there's no difference between 15.00 and 15, so I can carry on my division to see what we get to. How many 4s in 15? There were 3 and there was 3 left over. How many 4s in 30, or 4 times 7 gives us 28, which gives us 2 left over. How many 4s in 20? That's 3.75. And I guess ultimately what we want you to know, I mean, another approach to that question would be you could just count up in 40s and see how much you get. So 40, 80, 120, 160, and you can see that 150 would be somewhere there, so we can make 3 full lengths. Okay, so just to recap, I think the first thing is, think of it in terms of like a bar model there, you know, using a visual guide. You can see it was 240 centimeters in length. We took 2 45s away, which is 90. So 240 take away 90 left us with that 150. And then we want to find out, whichever method you like doing, how to split that up into 40s. I've given you 3 different methods there, and you should end up with the answer that there's 3 full lengths. Okay, question 14. Gavin, Harry and Isabel each earn the same monthly salary. Each month Gavin saves 28% of his salary and spends the rest of his salary. Harry spends 3/4 of his salary and saves the rest of his salaries, and the amount of salary Isabel saves to the amount of salary she spends is 3 to 7. Work out who saves the most of their salary each month. So work out who saves the most. Okay, now in order to tackle a question like this, there's 3 people. There's Gavin first, so let's have a look at him. So Gavin saves 28% of his salary. Notice that's in bold. He saves 28% of his salary. So let's keep that as a percentage. 28%, that's what we know about Gavin. Okay, Harry spends 3/4 of his salaries and saves the rest. A lot of people got this wrong, thinking Harry saves 3/4 of his salary. That's not correct. If Harry spends 3/4 of his salary, okay, if you spend 3/4, how much do you have left? You'll have 1/4. And at this stage you should know a quarter as a percentage will be 25%. So already we can see that Gavin saves more than Harry. And then finally, Isabel. Okay, the amount that she saves to what she spends is 3 to 7. Okay, and what I would do with this is first change this into a fraction. So the amount that she saves is the first number, so that number there. So that's going to be 3 out of, and another mistake that people think that it's 3 out of 7, but it's not. If you think about what it's saying, is you save 3 parts and spend 7. That's 10 parts altogether if you add them together. So it's actually 3/10, which as an equivalent fraction will be 30 out of 100. You times both the numerator and the denominator by 10, and 30 out of 100 means that is 30%. And then you can clearly see who works to work out who saves the most of their salary each month. Isabel saves the most at 30%. So therefore, Isabel saves the most. Okay, question 15. We need to work out 15% of 160 grams. Okay, there's lots of different ways to work out these percentages. Okay. For example, we could use what's called the multiply method. So 15% as a decimal would be 0.15. That's your multiplier, and then you times that by 160. That's one way of doing it. Or you could realize that 15% is the same as 15 out of 100, and then multiply that by, because of means times. So 15 out of 100 of 160. So you could do 160 times 15 divided by 100, or any other way. And then what you'll find is in the non-calculator paper, you'll tend to get fairly straightforward percentages to find. So 15% shouldn't really be difficult as long as you understand the one principle that to find 10%, we've got to divide by 10. Okay? If you've got 100% and you divide it by 10, you get 10%. Yeah? So in this case, 100% is 160 grams. So 10%, 160 divided by 10 will give us 16. And if you keep this in line, well, that doesn't mean that now I've got 15% that I'm trying to find. Does that mean I can just divide by 15 and that will give me the percentage? No, we work out 10% as more like a kind of marker. Now from this, we can work out any other percentage. To go from 10% to 5%, we just got to divide by 2, or we've got to half it. So if I keep that the same on both sides, 10% to 5% will give us 8. And then to work out 15%, we've already got 10%, we've got 5%. If I add those together, that will give me 15%, which in this case is 24 grams. Okay, question 16. P equals 4x plus 3y, where it tells you that x is 5, or x equals 5, and y equals minus 2. For part A, we need to work out the value of p, okay? And what topic this is substitution. So if I substitute these two values into that equation, okay? Let me rewrite the equation first. P equals 4x plus 3y, okay? And in this case, x is 5. So remember, when you've got a number next to a letter, you need to multiply them. So in this case, it's actually saying 4 times, where x is 5, so 4 times 5, plus, and then 3y will be 3 times minus 2. And notice that I put the negative in brackets. The reason for that is just to avoid making silly mistakes with that. Okay, one step at a time. 4 times 5 is 20, and then 3 times minus 2 is minus 6. And if we're adding minus 6, that's the same as taking away. So it's P equals 20 take away 6, and then 20 take away 6 is 14. So in this case, P equals 14. Okay. In part B, it says expand 4e bracket e plus 2. And what this is telling us is that we want to multiply 4e by everything in this bracket. So this 4e needs to multiply by e and by 2. Okay? If you think of that in terms of a grid, okay, 4e, try that again. 4e is what's outside the bracket, and that's being multiplied by e plus 2. So if I multiply those out, 4e times e gives us 4e squared. Okay? If you think about what that means, 4e times e is 4 times e times e. I won't make it 4ee. Okay? If you've got more than one being multiplied, that's where we use powers. So it'll be 4e squared. And then 2 times 4e gives us plus 8e. When we expand that bracket, we get 4e squared plus 8e. Now, in this final question, it says solve 3 bracket m minus 4 equals 21. Now, to solve this equation, your first step is to get rid of these brackets, okay, to expand those brackets. So just like before, we need to multiply what's outside by everything inside that bracket, saying we want 3 of these, okay? So again, let's do that as a grid. Other people can just do this straight in their head, that's perfectly fine. I'm just doing it the long way to make sure. It's always best when you're first learning this to really write it out fully and learn it so that you really make sure you get full understanding of what you're doing. So outside the bracket, you've got 3, and then you've got m minus 4. So we're multiplying, so it gives us 3 times m is 3m. and 3 times minus 4 will give us minus 12. So once we've expanded that bracket, let's rewrite that back into its equation. So we've got 3m minus 12 equals 21. So starting from there, we expanded the brackets and we've ended up with this. Now when solving this equation, what we're trying to work out is what is the value of this unknown. So what is m? All I know is that 3 times m, take away 12, is 21. So in order to solve this or to balance this equation, I need to get rid of this minus 12 first. Okay? In order to get rid of that or to eliminate that, I need to add 12. So if I add 12 here, on this side of the equals, 3m minus 12 plus 12 will leave us with just 3m. And because I've added 12 on this side, in order to keep it balanced and make sure that we're not changing the value of the situation, I need to add 12 to this side as well. And 21 add 12 will give us 33. Okay, so 3 times m is 33. To work out what m is, my final step here is to go from 3m to just 1, we need to divide by 3. Okay, and that gives us 1m. And then the same thing here, because I need to keep parity between both sides, I divide this side by 3 as well. And 33 divided by 3 gives us 11. So m equals 11. Okay, question 17. There are some chocolates in a box and 1 out of 4 of them of the chocolates contain nuts, or a quarter of the chocolates contain nuts. The rest of the chocolates do not contain nuts. We need to write down the ratio of the number of chocolates that contain nuts to the number of chocolates that do not contain nuts. And we need to give our answer in this form. So it's got to look like 1 to n, where n can be any number. So it has to be, so the first number is 1, and then n can be whatever it wants. Okay, well, whatever it works out to be in this case. So we know from here, now my method here is to think, well, a quarter of them contain nuts. So then you're thinking to yourself, how many do not contain nuts? If 1 quarter contains nuts, then how many quarters are left in a whole box? That would be 3 quarters. And as you can see, that's not in the form 1 to n. So in order to convert this into a whole number, what would I need to do to this fraction? I would need to multiply it by 4. Okay? If you think about it, a quarter, 1 out of 4 times 4 will give us 4 out of 4. Okay? Just to show you there that on the side, a quarter times 4 is the same as saying 4 over 1. 1 times 4 is 4, 4 times 1 is also 4, and 4 out of 4 is 1. Okay? And just like any other equation, to keep balance, to make sure I'm not changing the actual values here, if I times this by 4, I need to times this one by 4 and keep them the same. So 3 quarters times 4, remember, is the same as 3 quarters times 4 over 1. 4 out of 1, 4 divided by 1 is the same as just 4. So in this case, 3 times 4 gives us the 12. 4 times 1 gives us 4. So that's 12 divided by 4, which is 3, which gives us our answer 1 to 3. Now some of my students did really well in this question, and one of the methods I really liked here was realizing if it's got a quarter to 3 quarters, if you know your percentages, which you should know these percentages by now, a quarter is 25% and 3 quarters is 75%. And then if you simplify that down, you can either divide by 5 first or divide straight by 25. How many 25s in 25? There's 1. How many 25s in 75? Well, if I count up in 25s, it goes 25, 50, and then 75, so there's 3. So it'll be 1 to 3. Whichever method you choose is entirely up to you. There's different other ways to do it as well, but those two methods will work perfectly fine. Okay, question 18. Okay, what this is telling us is that there's a group A that are the multiples of 5 between 14 and 26, and then group B, which is the odd numbers between 14 and 26. Okay, let's start this off by writing out what are the multiples of 5 between 14 and 26. Well, we know multiples of 5 must end in either 0 or 5. So what numbers end in 0 and 5 between those? Well, the first one will be 15. Then the next multiple of 5 will be 20, and then 25. Okay, now the next bit, part B, odd numbers between 14 and 26. Those numbers, okay, 14 is not included because it's even. 15 is, then 17, 19, 21, 23, and then 25. And then 26 is not included because it's an even number. So the odd numbers between 14 and 26. So we've got all the group elements that we need. Now, what we're trying to do here is list the members of what this is written here. And that means A union B, or A or B. Okay? A union B, or A or B. So that means it can be either of the two. And what I find is that what makes this a lot easier is if you think of it in terms of Venn diagrams. So if I draw a quick Venn diagram here, I'll make that a bit neater. So let's just start off with the circles. Okay, and make sure you leave a good overlap because there'll be numbers overlap there. So if this is A and this is B, okay, the Venn diagram should have a box around it to contain all of the possible elements. Okay, now if I'm putting these numbers in, first of all, okay, what goes in the middle, that's the overlap. This circle represents everything in A, so these three numbers, and then this circle represents everything in B, so the orange numbers. So first, let's start off with putting the numbers that are in both, okay? So you can see the numbers that are in both lists. 15 is the same there, so 15 goes in the middle. And the only other number that's repeated is 25, so those two belong in both groups. And then, the only one that's left in A is 20, so that's 20, so you can see that's in this group but not in B, whereas the group of A is 20, 15 and 25 there. And then the numbers that are in B but not A, okay, the 15 and 25 are already there, so we're left with 17, 19, 21 and 23. Okay, and it's to list the members of A union B. What that means is, well, if you imagine here, and this is a blank one, if I've got A or B, okay, that means it can be in A or B, or it can be in the middle because it could be both, it could be either of those. So I want all the elements that are in A or B. So all these numbers, and by putting it in the Venn diagram, we avoid repeating ourselves and writing down the same number. So what do we end up with? We've got 15, 17, 19, 21, oh no, there's 20, 21, 23, so a nice little hint there if you cross them out as you're going, so 15, 17, 19, 20, 21, 23, and then we've got 25 left. So those are all the members of A or B, or A union B. Union's a good way to remember it because you're uniting the two circles, so everything that goes within there. Okay? Now for part B it says describe the members of A and this unhappy face symbol B. Okay? And this means A and B. And the way that we tend to remember this is the intersection, so A intersection B. And if you imagine what that looks like on a Venn diagram, okay, if that's A and that's B, the intersection is that middle bit there. So that would be A and B. Okay, so in this case, what are the members of A and B? It would just be 15 and 25. Okay, question 19a, we need to work out 2 1/7 plus 1 1/4, or 2 1/7 plus 1 1/4. Okay, now first of all, these are mixed numbers. These aren't just fractions by themselves. You're saying you've got 2 wholes and 1/7. So just to explain that a little bit further, if you imagine what it means by this, okay, let's start with 1 1/4. Okay, if you imagine this box to represent 1 whole, okay, and then you've got a quarter, so let's just split that up into 4s already. So you've got 1 1/4. Okay, so how many do you have altogether? You've got 1, 2, 3, 4, and 5 quarters. So you've got 5 out of 4. Okay. Similarly with 2 1/7, 2 1/7. If you imagine that represents 1 whole, there's the second whole, and then you've got 1/7, so a tiny little piece there. And if we split these up into 7s, 2, 3, 4, 5, 6, 7, 2, 3, 4, 7. So how many do we have? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then you've got 1/7 there, so you've got 15 altogether. So that'll be 15 out of 7. Okay? And what you actually have to, the easier way to do this, okay, now if I do start this again, okay, the easier way to do this would be to multiply by the denominator, then add the top. So if I do 2 times 7, because that's the 2 wholes, there's 7 and another 7, so that gives us the 14. So 2 times 7 is 14, plus the extra 1, that gives us 15 out of 7. Okay, and then I want to add 1 1/4, which we know is 5 out of 4, because you do 1 times 4, which is 4, add the 1, which gives us 5 out of 4. Okay. Common mistakes here, people think, oh, because you just add the top number, add the bottom number, and it's the same thing. But if you think about what we're doing, we're adding this with these pieces here. If you just add them together, the denominator is not going to be out of 11. We're not going to suddenly have split each of these shapes up into 11 pieces. Okay. What we can do is use equivalent fractions. So what goes into both 7 and 4? Okay. What do these both multiply to? Okay. We need to find the lowest common multiple. If you don't know what the lowest common multiple is, a handy hint is to multiply them together. It's not always the best method because you're not finding the lowest common multiple, but in this case it works and it is the lowest common multiple. 7 times 4 gives us 28, and that means that 7 can go into 28 and 4 can go into 28. Now in order to go from 7 to 28, we needed to multiply this fraction by 4. So the 7 is multiplied by 4, and in order to keep it equivalent, we need to keep these the same. Because the bottom is multiplied by 4, I also need to multiply the top by 4. Okay? So I need to do 15 times 4. I expect you not to know your 15 times table, so we can easily just write it out. 5 times 4 is 20. 1 times 4 is 4, and the 2 gives us 60 out of 28. And on this side, this fraction has multiplied by 7. Because to go from 4 to 28, we have to times by 7. And again, because I've multiplied the bottom by 7, I have to multiply the top by 7. And 5 times 7 gives us 35. And then now we can add the two fractions because they've now got the same denominator. Okay, 60 out of 28 plus 35 out of 28 will give us something out of 28. Okay, we don't ever add the denominators. Okay, because if you think about what it's saying, something out of 28 plus another something out of 28 will give us an answer out of 28. We don't add the denominators. And if I add the two top numbers, that gives us 95 out of 28. Okay, there's nothing about simplifying. If you wanted to write it as a mixed number again, because the question was given as a mixed number, if you wanted to, it's not compulsory, you can work out how many 28s there are in 95. Okay, so I'm doing 95 divided by 28. I wouldn't use the bus stop method there, it's quite a difficult one. We can just count in 28. So 28 times 1, and then 28 times 2 is 56. And then 28 times 3 is 84. Okay, and there's not going to be any more 28s within 95, so we've got 3 holes, and then from 84 to 95, what's left over? So 95 take 84 gives us 11, so that'll be 3 and 11 out of 28. Again, this part isn't compulsory, but it is good maths, so if you know how to work this out as a top-heavy fraction, you can also work it out as a mixed number. Okay, now part B is a different type of working here. It's saying work out 1 1/5 divided by 3/4. Okay, now first of all, let's change that to an improper or a top-heavy fraction from a mixed number. It's always best to work these out. It's almost impossible to work this one out without doing that. I mean, you could, it's just much more complicated than it needs to be. Your first step should be to change it into a regular fraction, even though it will be improper because it will be top heavy. Okay, so 1 times 5 gives us 5, plus the 1 gives us 6 out of 5. And we need to divide that by 3/4. In order to divide a fraction, we need to actually multiply by the reciprocal. That's the method that we use. Multiply by the reciprocal. And what the reciprocal is, okay, if you think about a number, say for example 3, the reciprocal will be the opposite of 3, which will be 1 out of 3. So it'll be that as a fraction. If it's already a fraction like this one, so for example if you had 2/3, the reciprocal would be 3/2. Okay, another handy hint that people use to remember this is KFC. So we keep, we flip, and we change. Okay, and what that means, I keep the same fraction, the first fraction as it was. Let's just change colour there. So 6 out of 5 stays as it was, and then we flip the second fraction. What that means is what I was just talking about there, that's the reciprocal. So if I flip that round, you get 4/3. And what we mean by change is it went from divide, and now it's going to be times. And what that gives us is 6 times 4 is 24, 5 times 3 is 15. Okay, really important to remember, when you're multiplying fractions, you do just multiply the top and multiply the bottom. You just multiply the numerators and denominators together. When you're adding or subtracting, then the denominators need to be the same. That is something that always catches people out. I guess you've got to kind of make a note that adding and subtracting fractions, the denominators must be the same. And multiplying or dividing, it's a different method. You can just multiply the top and multiply the bottom. If you're dividing, you need to multiply, but you need to find the reciprocal first. You need to flip it first. Now, notice this isn't the final answer because it says give your answer as a mixed number in its simplest form. Okay, let's simplify it first. So what goes into both of these numbers? Okay, and it's quite a difficult one because you wouldn't think that there's, because that's an odd number and that's an even, that there is a common factor apart from 1, but actually 3 goes into both. Okay, how many 3s in how many 3s in 24? There will be 8. How many 3s in 15? There will be 5. So we've got 8/5. And to change that into a mixed number, what this actually means, if you notice, the division sign is a fraction. It's that divided by that. So if that's what we're doing here. If I do 8 divided by 5, how many 5s are there in 8? There's 1. And what's left over? There's 3 left over. And and that will be left as 1 and 3 out of 5. So 1 and 3/5 is our final answer. Okay, question 20 says, in a village, the number of houses and the number of flats are in the ratio 7:4. The number of flats and the number of bungalows are in the ratio 8:5. There are 50 bungalows in the village. How many houses are in the village? Okay, so let's write out what we've got so far. So the number of houses to flats are in the ratio 7:4. Okay, and then the number of flats to the number of bungalows. Now if you keep this in line, so the number of flats is 8:5. Okay, and that was number of flats to number of bungalows. So I'll label that with B. So now we've got them in a line, but there's bits missing here. And what you can't do is just bring that down and say that's 7 to 8:5, because that's 7 to 4. So if you imagine there's 7 houses for every 4 flats. Okay, so how can we rearrange that? Well, if there's 7 houses to every 4 flats, that doubles to become 8. So that means we can just double this one and we get 14 to 8:5. And now we've got houses to flats to bungalows all in one line. But that's not the question finished yet, because it said there are 50 bungalows in the village. So we don't want 5, we want 50. So that means that's multiplied by 10. And in order to keep parity, that means we've got to multiply these by 10 as well. So that gives me 80, and that gives me 140. Okay, so how many houses are there in the village? Well, if there's 50 bungalows, then there's 140 houses. Okay, in this question 21, Renee buys 5 kilograms of sweets to sell, and she pays £10 for the sweets. So let's see what that looks like. Let's just make a little diagram. There's 5 kilograms of sweets, and she pays, so that's the cost price, is £10. Okay, now Renee puts all the sweets into bags. So if you imagine, she splits that all into bags, and she puts 250 grams of sweets in each bag. So if you imagine what that looks like, she's got loads of little bags, and in each one there's 250 grams. Okay, and then she sells each bag for 65 pence. Okay, so working this out from the beginning, let's start off with, well, if she's got 5 kilograms worth, and we know that she's splitting them into 250 grams, we need to work out how many 250 grams go into 5 kilograms. And notice the difference in units there. Okay, first of all, 5 kilograms is 5,000 grams. Okay, and we're going to divide that by 250 grams. And that will tell us the number of bags she needs. So first of all, we can cancel out the zeros because we can divide both the numerator and the denominator by 10, so the fraction stays the same. So I'm working out 500 divided by 25. How many 25s in 5? None. How many 25s in 50? There's 2. How many 25s in 0? There's 0. So that tells us she needs to buy 20 bags. Okay, now we can work out how much she made from selling these, because if there's 20 bags and she sells each of them for 65 pence, that means I need to do 20 times 65 pence, and that will tell us how many pennies she made. So in order to do this, I think the easiest way would be 65 times 2 and then times by 10, because you've got to realize that 20 is the same as 2 times 10, and then we're timesing that by 65 pence. 65 times 2 is 130, times that by 10, and we get 1,300 pence, which does equal to 13 pounds. So 13 pounds is her actual, what we call a gross, the gross amount. Okay, not gross as in disgusting. That's the gross amount. That's how much money she's made. That doesn't tell us what profit she's made. To work out her profit, okay, we need to take away how much she spent on the cost. So in this case, £13 minus the £10 means she made £3 of profit. And again, this wasn't asking for just work out her profit, it's her percentage profit. So then to work that out, we need to do, well, it's £3 is how much she's made out of, what did she spend? £10. So 3 out of 10. And to change a fraction into a percentage, we just multiply by 100. That gives us, if you imagine that's like saying 3 over 10 times 100 over 1. So that'll be 300 divided by 10, which leaves us with 30. And that tells us she made a 30% profit. Okay, question 22. A cycle race across America is 3,069.25 miles in length. Juan knows his average speed for his previous race is 15.12 miles per hour. For the next race across America, he will cycle for 8 hours per day. We need to estimate how many days Juan will take to complete the race. Now, first of all, one of the biggest mistakes that my students made here was not realizing this is an estimate question. This doesn't mean you actually have to work out using these values, okay? So what values have they given us? This is the length that he's going to be traveling, so the distance, okay, will be, if you round this up to one significant figure, you'll get 3,000 miles. Now, his speed, okay, 15.12 miles. You can either round that to 20 or you can round it to 15. I would say, looking at this, the values here, because that's 3,000 and 15, and chances are you're going to have to divide at some point, I would keep it as 15 because 15 goes directly into 30. So we're going to say his speed is 15 miles per hour. Okay, notice that they're all in miles and it's done in per hours. Okay, and the object of this question is to work out the time taken. Okay, so how many days he will take to complete the race. So the first thing we need to work out is how much time will it take with this speed at this distance. Okay, now you should know by now the speed, distance, time triangle. Okay, in this case I'm working out the time. So that means we're doing distance divided by speed. If you imagine the line there, this distance divided by speed. So we're going to do 3,000 divided by 15 miles per hour. And if we work that out, you can use a bus stop method if you struggle with that. How many 15s in 3? There's none. Carry that along. How many 15s in 30? There's 2. How many 15s in 0 and 0? There's 0. So that tells us, now if you think about the units here, we've done 3,000 miles divided by 15 miles per hour. And when you divide that, the miles cancel out, so you're left with just hours. So in this case, it's 200 hours that would take him to complete this race. Now that's again not the full ending of the question, because it said estimate how many days Juan will take to complete the race. If he cycles for 8 hours per day, and you know he's got to do 200 hours, we need to split that 200 hours up into 8 hours per day. And when you divide that, you can simplify it first if you like, but otherwise you can just work it out by doing 200 divided by 8. How many 8s in 2? None. How many 8s in 20? There's 2, with 4 left over. How many 8s in 40? There's 5. So that will tell me it will take him roughly 25 days. Okay, for part B it says Juan trains for the race. The average speed he can cycle at increases. Okay, it is now 16.27 miles per hour. How does this affect your answer to part A? Well, you can answer this in a variety of ways. First of all, if the speed increases, a speed increase would denote that the time taken will decrease. That's a perfectly legitimate answer. If you said something like, for example, if it's now 16, I would still round it down to 15, then you can also say that actually it won't affect your answer in any way. And for 1 mark, they're not expecting you to work out, well, let's estimate it using 16 and then see if this changes up or down by 1 day. You would expect it would actually decrease by 1 day, but depending on your explanation, the mark there is to really just kind of judge, do you understand that the speed increasing means that the time taken will decrease. Okay, question 23. Here's a solid square base pyramid VABCD. Okay, so that means in front of us we have this square base pyramid. Now if that's 6 across, because it's square base, that means that this distance across here will also be 6 centimeters. Okay, the base of the pyramid is a square of side 6 centimeters, the height is 4 centimeters, and notice the height is 4 centimeters. Okay, M is the midpoint of BC, so M is the midpoint of BC, and V to M is 5 centimeters. So that's telling me that the height of this triangle is 5 centimeters. For part A, we need to draw an accurate front elevation of the pyramid from the direction of the arrow. So if that's the front view there, what will this pyramid look like from that view? Now, this is about 3D modeling and being able to realize that if you were to look at this from the front view and not be able to see anything else, all you would see in effect is, well, a triangle, and the base of the triangle will be 6 centimeters across. So 1, 2, 3, 4, 5, 6 centimeters across. Now the triangle, even though we've been told that the height here is 5, that's a sloping height. The actual height of the pyramid is 4 centimeters. So from the middle there, 1, 2, 3, 4, your height will be there. Just adjust that. Exactly 4 centimeters, and that is what your front elevation will look like. Where people go wrong in this question, they think because that's 5 centimeters that the height here would be 5, but it's actually this length that's 5 there. The height of the actual triangle will be 4, going that way, and then the width needs to be 6 across. And if you notice, you can split that up into triangles where that's 3, and that's a Pythagorean triple there. If you recognize that, you're working at a much higher grade. Now for part B, it says work out the total surface area of the pyramid. Now before we work out the surface area, you've got to think about what that means. I want the area of all the sides added together. An easy way to do that would be to think about what it would look like if we opened it up. That would be the base, and then it would have 4 triangles. And because this is square based and this is 6 by 6, that means the area here would be 36 centimeters squared. Now for each triangle, the base is 6. So if you imagine this one here, the base is 6, and then the height, which has been told to us, is 5 centimeters. So what's the area of each one there going to be? Well, area of a triangle is base times height divided by 2, or half base height. So in this case it would be 6 times 5 divided by 2, which is 30 divided by 2, which is 15 centimeters squared. So if that's 15, now luckily all 4 of those will be 15. So if I want the total surface area, I need to add these numbers together. So for my final answer, I need to add 36 plus 15 plus 15 plus 15 plus 15. Okay, 4 5s make 20, plus the 6 gives us 26. And then if we add these numbers, that's 2 plus 3 is 5, 6, 7, 8, 9. So the total surface area of this shape will be 96 centimeters squared. And don't forget to put the units in, because there's no units given, that alone is worth a mark. Okay, question 24. It says a pattern is made from 4 identical squares and the sides of the squares are parallel to the axes. Okay, and it tells you that this point A is 6 across and 7 up, and point B has coordinates. In fact, what might help if we put some lines in that tells us that there to here, we can work out what distance that is. Okay, so if that's 6 across there, now remember coordinates are always in the XY format, so it's always across and then up or down. In this case, that tells us it's 6 across there, and for this one, that tells us it's 38 across there. Okay. It also tells us that point B has coordinates 38, 36, and again, if we go across this way, this time is telling us the height. So this is the second number in each of the pairs of coordinates. So in this case here, that was 6 across, that would be lemonade or 7 up, and this one would be 38 across and then 36 up. And we need to work out the coordinates of this point here, which is not exactly in center to all of this. Now, having put that information on, we can deduce that the distance between here, okay, which is 4 exact lengths of each square, okay, the difference between them will be 38 minus 6, which is 32, and then there's 4 lengths of a square there. So if I divide 32 by 4, which gives us 8, that tells us that each square is an 8 by 8 square. So if these are all 8s, now if you imagine from there to there, that's 8 plus 8 plus 6, which gives us a total of 22 units across. So that's the distance across. Again, will be 6 plus the 8 plus the 8, and that will get us to that center point there. And then going upwards, the easiest way to work this one out would be starting from the top there. If we know that's 36, to get to here, there's exactly 2 squares again. So if I do 36 take away 8, that gives me 28, and I take away another 8, that gets me to 20. So that tells me my center point is 22 across and 20 upwards. So it will be 22 across and 20 upwards will be my final coordinates of C. Okay, question 25. It says on the grid below, draw the graph of y equals 1 minus 4x for values of x from minus 3 to 3. Okay, now in order to draw this graph, you can do it in 2 ways. You can either use the properties that you know from here. For example, the gradient here would be minus 4 because the coefficient, the number in front of x, is minus 4. So that tells me it's going down by 4 every time. And it also tells me that the y-intercept here is 1. So it starts there and it goes down by 4 every time. If you struggle with that, you can also use using a table. Okay. In order to do that, we know what our x values are, and maybe do that. Very neat. Now you can either do them for all the numbers from minus 3 to 3, or you can think, well, if I just separate these into 3, I can do minus 3, 0, and 3, and that will cover all the bases in between. Okay. Now, the way this formula is written, it tells us that y equals 1 minus 4 times whatever x is. So in this case, when x is minus 3, then y would equal 1 minus 4 times minus 3. So that will give us 1 minus 4. First of all, remembering BidMaths, we need to do the multiplying first. Minus 4 times minus 3 will actually give us plus 12, because it's minus times a minus gives us a plus. So y equals 13 at minus 3. The middle one should be the easiest. When x equals 0, y equals 1 minus 4 times 0, which just gives us 4 times 0 is 0, so it's just 1 minus 0, y equals 1. And then finally, when x is 3, then y equals 1 minus 4 times 3, which is 1 minus, again remember to do the multiplying first, don't do 1 take away 4, which is minus 3, and then times that by minus 3. Okay, we've got to follow the rules of BidMaths, multiplying first. So minus 4 times 3 gives us minus 12, and then 1 take away 12 will give us minus 11. Okay, now if you think about what we've got here are coordinates. So if you imagine there's a comma in between them, we need to plot these three coordinates. So minus 3, 13. So minus 3 across, and then down 13. There's minus 12, so minus 13 will be there. And then 0, 1, 0 across, 1 up. Just realized I did that the other way around. It should be, sorry, minus 3 and then 13 upwards that way. Then 0 and 1. And then 3 across and minus 11. Should be there. And then once you've got your points there, you just need to join them up as so. That's perfect. And that is the graph of y equals 1 minus 4x for values of x from minus 3 to 3. Now, as I said before, you could have done this by just realizing your y-intercept here. Okay, remembering y equals mx plus c. Okay, this is actually written in a slightly different format. It's written as c minus mx. So it's telling us that c, or in fact let's say y equals c plus mx anyway. C is your y-intercept, which is 1. And then the gradient here is minus 4. That means for every 1 unit across, it's going down by 4. So you could draw it that way as well. Okay, question 26. Okay, A equals 5, 2, where this is a column vector. Okay, and B equals minus 1, 7. We need to work out 2A plus B as a column vector. Okay, just a quick reminder on what a vector is. So the vector 5, 2 will look like this. That tells us it's a horizontal distance of 5 across and then 2 up. These aren't the actual vectors, these are the scalar values. And this is our vector A, which is 5 across and 2 up. So that is the vector A there. Okay, so if we want 2A, it's going to be double this. That will give us 10 and 4. Because if you imagine 2A would be like that, so that would be, if you imagine that's gone like that, I've got 1A and then another A movement, so that's 2 across and then 2 again, so that would be 10 across and 4 up. So 2A plus B, 2A is 10 and 4, and then we need to add B, which is minus 1 and 7. So if you imagine what's happened here, it's gone 2A and then it's gone B, which is minus 1 across, up 7. So it's going to be off the page there, it's going to be over there somewhere. Minus 1 across and then up 7. So to work out the answer here, we just need to add the top value. So 10 add minus 1 is 9, and then 4 add 7 is 11. So 2a plus b as a column vector would be 9 over 11.